So here's my claim. Sine, cosine, and tangent are functions. And when we say they're functions, functions have inputs and outputs. So we do sine of an angle, and that gives us a ratio. In this case, the angle is the input, and the ratio is the output. We need to switch this around. We need to cancel out this sine thing and get theta by itself. We need to have theta be the output. How do we cancel out things in algebra? Well, how do we cancel out addition? Subtraction. What about powers? Roots. We use the inverse of the operation. But there aren't operations here. There are functions. And so the key thing here is we don't use an inverse operation. We use an inverse function. And this is what it looks like. And it's going to be like, it's kind of dumb simple in a way if you don't really know what's going on, right? So we say sine of theta is equal to some ratio. And then we use what's called the inverse sine function. And it looks like this. And just like addition and subtraction cancel out, multiplication and division cancel out, sine and sine inverse cancel out. We didn't spend a lot of time, we haven't really talked about inverse functions, but functions have inverses. And if these two things cancel out, what are we left with? Theta. And so now, instead of having sine of some angle equals a ratio, we end up with an angle is equal to sine inverse of a ratio.
That's on the calculator.
What's that?
That thing is on the calculator.
How do you know it's in the calculator, bro? Where'd you see that? Let's see. Many things on the calculator. Oh snap. Look. We got sine, cosine, tangent. What do you see right there? What's that blue thing right there? Sine inverse. And so if we hit this second button, second sine inverse, we get that. What was the ratio that we found?
0.5.
We found 0.5 for that triangle. What should be sine inverse of 0.5?
30.
30 degrees.